So it is theoretical again, and a straight line is the shortest distance between one point and another. So you won't nice. So this, if you measured it with a ruler, wouldn't be as quick as that. Yeah. Sorry. And then a circle is a 2D, so it exists only on a flat surface, theoretically. We're going to pretend that the circles are equal, as in the radiuses are all equal.
But they're just
Yeah, they're not going to be exact. So we have this line. We're going to call, we have this line. We're going to call this point alpha and this point beta. And now we can use, so the way we can make two circles with this as the radius, we can use this as the center and alpha to beta as the radius, or we can use beta as the center and beta to alpha as the radius. So beta as this is what it would look like if we had beta as the center and beta to alpha as the radius. That's what the circle would look like if I...
Hey.
We talked about this already. And we also know that all radiuses of a circle are equal. And so if we draw a line from here to here, here to here, and then another line here to here, then this has to be an equilateral triangle. If it was equal, it would be an equilateral triangle because since an equilateral triangle, all sides are equal, then there's only one way you can assemble all the sides, and since all the radiuses of a radii of a circle are equal, then these lines have to be equal because the line from here, alpha, going to the circumference of the circle with alpha as the center and the line alpha to beta as the radius, this is also a radius, and we know that radiuses are all equal. Make a line that starts from this point and ends somewhere else that's equal to this line without using a ruler that has centimeters or inches. And so we're going to pretend we're not going to look at it. So we're going to label this point alpha, this point beta, this point gamma. Okay? Given these points, you can construct a line between alpha and gamma. Okay? And now we can use, given this line from alpha to gamma, we can use it as the radius of how many circles? Does anyone know? Two. There you go. Two. Because, no, you said 7. Okay, because of as we looked at in proposition 1. So first we're going to make a circle. We're going to construct a circle with alpha at the center and the line alpha to gamma as the radius. That's not what we're doing. Okay, and here, you know how I said at the start that we're trying to make a line that's equal to this line without using the ruler, right? So we're going to name that point epsilon, but we're going to try and find that point, where that point can be. So now, what can we do with this line? What can we create with it? Ben?
No, just keep on.
Daniel?
Equilateral? What?
We didn't learn how to make one of those yet. What can we make?
Circle.
Circle? Yes. What part of the circle would this be? This line gamma to beta? A radius, exactly.
Oh, yeah.
Now, this is, well, if we extend, see epsilon, we call this line epsilon to gamma because those are the two endpoints. And if we extend that line to the circumference of the circle with gamma as the center and the line gamma to beta as the radius, this line from gamma to the circumference will be equal to gamma to beta. Does any of you know why? Leslie?
Well, I don't exactly know why, but what's the point of doing all of that if you have no ruler?
Because back in those days, they never had a ruler.
But they got like a piece of wood. Can you make it? And then mark it?
Yeah, that's what this could be. No, but they don't have any. Yeah.
Because if you take this, that center is the same as this other center, and it brings a straight line with the other point.
Let me.
Yeah, it'd bring a straight line with that one.
Yeah, and why would this be equal to that one?
Because they're both connected from the center to the outside.
They're both radiuses. And
There you go. There you go. Yeah, as we discussed. So we're gonna call this point. We're gonna call it epsilon pi.
Like this on top.
No, that's epsilon is what we're gonna try and find, which is the point where
I see the
this
epsilon.
line. Pardon me?
I see that epsilon.
The epsilon?
All of them?
Yeah, epsilon.
No, but another one.
Epsilon. Oh, what? What?
Epsilon. Two circles.
Yes. You can make another circle. Okay. And now, see this line epsilon to yes, alpha? Yeah? Epsilon to alpha. What we can do is we can extend it to there. Okay? So we're gonna I'm gonna label this epsilon. So I think this line equals this line. Does any of you know why?
Because the radiuses and a radius should be the same. And they're both coming off the same angle off the middle point of your equilateral.
That's a good point, but yeah. Well, see, this is the center of this circle. This line is the radius. So what is this line?
It's another radius.
Yes, of this.
Yeah.
But we're looking at only here to here. How can this point be equal to here to here? Why?
Equilateral triangle.
And all sides have to be equal, right?
Yeah.
And then, but why does that make this equal?
Because both radius were the same, so if you cut off the same amount on both lines, they're still the same.
There has to be the same, right? Okay, that's like saying, say we label this 7, and we label this 7, and all of it is 10 on each side.
Mm-hmm.
Then what are we left with? If you subtract it, 3, exactly. So it's sort of the same as that. And so that means this one has to be epsilon. But we did there to there. Now we need to do there to there. Gamma to beta. Why is this equal to gamma and beta?
Because gamma and beta come off the same point, and if the gamma and beta one, if it's the same as it's the same as the other. That
This one? Yeah.
Yeah.
That means it has to be the same
Same
as
as this one.
because we already down.
Yeah.
Yeah. There we go.